Alrighty, welcome back, boys and girls. It's your main math man, Mitch Jen, coming to you live from Mayfield. In this video, we're going to be working with this, solving and graphing those two-step inequalities. And so it's going to be very similar to, again, solving those one-step equalities, and it's going to be very similar to our two-step equations. And so you want to make sure that you're using those same ideas. If you need to model them, again, to be able to see how to do it, that can be a helpful way for you. And so it says, thinking back to yesterday, it says, what is our multiplication and division rule? And so think back, well, what is that referring to? And it's referring to this. It's saying when we multiply or divide by a positive number, the inequality symbol stays the same. However, when we multiply or divide by a negative number, the inequality symbol changes. So again, make sure you have those two differences for yourself. Anytime you see that we're multiplying by a negative or dividing by a negative, that's when we change our sign. If we, happen to get a negative as the result, it might have to change, but it's only when we multiply or divide by a negative. So again, make sure you can see those differences. So for example, in this first one, let me peel this across. And so it has, just a recap from yesterday, again, these are those one-step inequalities. And it also, again, this goes with that IXL section, x point, I believe it's x.5, again, solving those one step and graphing them. So, I just figured I'd write this in here so that way you guys can see it. Alright, anyways, so it says solve, and it has x divided by 4 is greater than positive 10. So again, our inverse operations, since it gives division, we have to multiply. So I'm going to multiply both sides. Again, I use parentheses to show multiplication. Multiply both sides by 4. Again, that's that multiplicative inverse that we've had. And so multiply both sides by 4. On the left, it cancels out. And so what comes down as x. And then for the inequality symbol, did we multiply divide by a negative? We did not, and so it stays the same. Let's try drawing that a little bit more normal. Alright, so we have greater than, and then 4 times 10 is 40. Alright, so again, to be able to graph it, just like we've been doing, we would say, alright, we have 40, we have 1 above, and 1 below. And we say, alright, we're going to have an open circle on 40. And since our variable is on the left, we can see that our arrowhead, meaning when we go to shade it in, will match our inequality symbol. So I can see that, hey, this is going to be going and I'm pointing to the right. So it's going to be, let me actually get that highlighter out. It's going to be shaded in going to the right. So any value greater than 40 is a solution. Last question you can ask for yourself anytime you get an inequality is 0 a solution? So you would say, for this one particularly, we would say no, 0 is not a solution since it is not included in that set. Again, it would be to the further left as you go down, and so we would not include it. Moving on, it has negative 2x is less than positive 6. Again, make sure that you can always divide by the coefficient, and so we're going to divide by negative 2 to both sides. Right away, before I do any calculation, I see, hey, stop right there. I see I have that I'm dividing by a negative. So right away, I can change the direction of my inequality symbol. So again, make sure that you are changing that direction. And so you can write that first. And so now I have what? Well, on the left side, I have an x. On the right side, I have a negative 3. When you go to graph it, Again, I can say something like this. I could say, all right, let's do the value in the middle. So I have a -3, I have 1 below, and 1 above. And then I take and shade it in. So I'm going to have, again, I'm going to have an open circle for this one. So I'm going to have an open circle. And I'm going to be still going to the right, since our variable is on the left. And so it's saying any value greater than -3 is included. And then we answer the question, is there a solution for this one? We would say, yes, it is. As you can see, hey, what would be, we could keep going here. We could say, all right, I have a -1, and I would have 0 after it. So I would be able to kind of picture and see if that number line would keep going. All right, last one on this recap. I have x divided by a -3 is greater than +9. And so let's do it like this. Again, if it gives you division, do the inverse. So we're going to multiply both sides by 3. Excuse me, I'm going to multiply both sides by -3. And because I do that right away, I need to make sure, hey, I change the direction of my inequality symbol. So I say, instead of greater than or equal to, I'm now going to have less than or equal to. Again, that makes sense because at all times it has to be a true statement. So now we're going to have, on the left side, we're going to have an x, and on the right side, we're going to have a -27. When you go to graph it, we're going to say this. We're going to say, all right, plot those numbers like so. Again, be able to kind of look for that value that you're given. Usually you will be given a number line, but we want to make sure that I can graph it however which way we can. All right, so again, when we go to shade, again, we're saying anytime we shade these values in, we're including them in the solution set, meaning if we were to plug these values in, it would be a possible answer. So if we're saying it's less than or equal to, we're now going to have a closed circle. So again, filled in line, filled in circle. So I'm going to have a filled in circle on, let's try that. Well, actually, I can I just draw a circle? Perfect. Something like that. There it is. I'm going to have a filled in circle on -27, and I'm also going to have that it's going to the left. So again, notice that these are 3 separate problems, but I wanted to at least demonstrate how those work. Again, this should be a recap from yesterday. However, moving on, it says for 2-step examples, same kind of similar idea. Make sure you're doing your inverse operations at all times. Be able to isolate the variable, that means get it by itself, and then you can plot the solution. So we're going to have it like this. I'm going to have, all right, I'm going to have my inverse operations. I'm going to try to combine my like terms, meaning I'm going to try to get all my constants on the other side. So I'm going to have -7 to both sides. These cancel out, and so I'm left with 2x. Since I did not multiply or divide by a negative, I keep the inequality symbol the same. And then on the right, I have 4. Last step, be able to divide by 2, since that is our coefficient. And I see that, hey, I have x is greater than 2. So now, all right, you say, for my answer, again, is simply this. And the way you would write it is just like this. You're saying any value, again, any value greater than 2 is a solution. So all values greater than 2. So it could be, 18 is a possible answer. 22 is a possible answer. Anything greater than 2. Again, when you go plot it out, let's use that pink for ourselves. So I'm going to write the value that it's on. So it's on 2. I do 1 below and 1 above. I'm going to have open circle for this one. So I have an open circle on 2 there, and it's going to be shaded in to the right. So it's saying anything greater than 2. Last question, as always, do we say, is 0 a solution? We would say, no, we did not include it in the shaded solutions. Again, you would see that, hey, it's to the left of our answers. You're also able to check your solution just like we did with equations. So using that wonderful Desmos calculator, I can bust that open, make it nice and big for us. So I type it in just exactly how it looks. So I'm going to type in this left side. So it was, what, 2x plus 7. And so now, okay, anytime we go to plug in a value, we have to make sure that it's going to say, all right, whatever comes out, it has to be greater than, and then what's this value? Well, it has to be greater than this 11. But we want to make sure that we're picking a value that is greater than 2. So again, when you go to put this input value, meaning when we go to define what our x is equal to, I need to pick another number. So let's pick something that's greater than 2. So let's say 3. And if you see, again, it has it right here, since it would have it like so. Again, it's saying that this, let's say this part in orange, let me highlight this part in orange, it's saying that that amount is 13. And since 13 is greater than 11, we know we are good. Alright, moving on. Same kind of idea. Inverse operations, we want to isolate that variable. And so I'm going to draw my railroad tracks or river, whatever you want to do. A lot of people on the quiz for equations just drew these railroad tracks and then stopped, which is beyond me. I don't understand how you can just stop there, but I guess it's difficult for some to try anything at all. But that's okay. That's what I'm here for. If you need to, again, hey, what kind of 7 is this? Well, I can say that it is a positive 7. So if you don't see a positive negative symbol there, or excuse me, a positive or negative sign, you can make sure that you're writing that it is a positive. And so that means we need to do the inverse, which is minus. So I'm going to say similar setup, minus 7 to both sides. What happens on the left? The 7's cancel out. The negative 5x comes down. Since we did not multiply or divide by a negative, I keep the inequality symbol the same. Again, even though I got a negative as a result, that's okay. I'm keeping it the same. It's only when you multiply or divide by a negative. Which, speaking of, that's what we're going to do next. So we're going to divide both sides by negative 5. And because we do just that, you must change that inequality symbol. So again, I'm going to change that direction. And I can say, all right, x, and then is greater than negative 4. And so what is this saying? It's saying this. It's saying all values greater than negative 4 are possible solutions. So, you could have a negative 3 since it is higher than negative 4. Again, that would be a possible answer. So, again, when you go to graph it on that number line, I have a negative 4 in the middle, I have 1 below, and 1 above. Let's see, I have an open circle now. I'm going to draw an open circle, and since our variable is on the left, I can match that arrow direction, and so I'm going to shade everything above negative 4. That last question, as always, is 0 a solution? You better believe it. Yes, it is included in that possible shaded solution. Again, you don't really see 0 on this number line. However, you know for sure that if you kept going on that number line, which is why we draw the arrow, if you kept going, you would include 0. Again, to be able to check that, I'm going to big screen that Desmos calculator, type in exactly how it looks. So I had a 7 minus 5x, and we're trying to get a value that is less than 27. So we need to pick, a value that is greater than -4. So let's say, like I said, a -3. Since this 22, again, notice how this 22 is less than, and I can again highlight in orange. Again, that left side is still less than 27, which since we got 22, that's what we're looking for. And we also said, hey, what about 0? Is 0 possible solution? Yes, it is, since again our result is still less than 27. Again, you can make sure you're trying it out on that Desmos calculator for yourself. All right, last one together here before I keep messing up. So it says positive 12x plus 2x is greater than 20. Again, you want to now check by hand. So let's do just that. Again, I can draw those railroad tracks, river, whatever you want to call them, training wheels. Inverse operations, subtract 12 from both sides. So I have minus 12 to both sides. Did we multiply, divide by a negative? No, and so our inequality symbol stays the same. On the left, the 12s cancel out, and the 2x comes down. On the right, we have 20 minus 12 is positive 8. And now we can divide by the coefficient, and we have 2 divided by 2 to both sides. Did we multiply or divide by a negative? No, and so it stays the same. And we have x is greater than 4. So again, the conclusion is all values greater than 4 are solutions. Now let's make sure we can check. So let's check. Let's actually hold that thought. Let's graph while we are ahead. So let's see. We have, what do we say? Let's keep that 4 in the middle. Again, we do 1 below, 1 above. Again, be careful if you are numbering your number line. You understand where you're at, where 0 is at, whether you're in the positives or the negatives. That way you are good. And so we're going to have an open circle on 4, and we are going to be shading everything above 4, so everything to the right of 4. Alright, so now we can check it. I didn't want to get ahead of myself, so let's make sure we do this. So it says we check using a similar method as equation, and that we're still looking to make a true statement. However, you must pick a value greater than 4. Again, normally we plug in x equals 4. However, since it is strictly greater than 4, we want to make sure that we're plugging in something other than 4, and we want to make sure that it is greater than 4. So, I don't know, it's a wild shot in the dark. Let's try a positive 5. So I'm going to do in green, I'm going to say a positive 5. And so how do we do this? Well, again, we simplify using order operations. We do 2 times 5 is 10. Bring down the rest, so we have 12 plus 10. And we're saying, is this greater than 20? 12 plus 10 is 22. And we're saying, yes, this is true. 22 is greater than 20, so we know we are good. Again, normally with equations, you should get the same thing on both sides, but we're still just looking for a true statement. Again, make sure you're seeing that difference for ourselves. Last question on here, it says, is 0 a solution? Well, no, but why is it not a solution? Well, if you look at the graph, we can say that 0 is not a solution since it is not included in the shaded values. So again, it would kind of be, to the left of our value on here. Again, as it went further and further to the left, it would approach 0. However, all our solutions are above 4, so anything greater than 4 is a solution. You can also plug it in and do the inequality that you have. You would say, all right, can I plug this in and keep it true? Well, let's see. Is 0 greater than 4? That's with a question mark. And your answer should be still an astounding no. Be sure to ask questions for yourself. I will have these 4 problems on the board, hopefully for you guys to do. Again, on your own or with a partner, try these out. Again, these are just simple 2-step equations. Inverse operations, make sure that variable is on the left side, and give it a try.